Hello everyone. Welcome to the second part of the CDK series. In this video, I'm planning to talk about the L3 constructs, lookups, context values, and passing values between stacks in CDK. So let's get started. I have a sample stack set up. Yep. So as you can see, there are two stacks defined. One is the ECS stack and another one is a VPC stack. Um, I haven't configured the VPC stack for now. In the ECS stack, you can see that there is a cluster. This is a normal ECS cluster. And another construct that I've defined here is the application load balance Fargate service. So what this does is that this is a L3 construct. So L3 construct would be abstracting much more than a simple resource or a what do you say, couple of resources. So this is a common pattern that we have in AWS, right? So you have a ECS service and then you're serving it in front behind a ALB. So this 10 lines of code would actually deploy that for you. It will deploy an application load balancer, create a target group, configure your ECS service to be part of that target group, and it'll nail the roles, the permissions, the security groups, and everything for you. So this is from the AWS ECS patterns library. And let me switch over to Chrome. Yeah. This is the documentation for that. You can see there are several L3 constructs. So these are pretty much straightforward. As you can see from the name itself, ALB EC2 service would actually create an ECS service that is configured to use EC2 capacity. And Fargate service would be using Fargate as the capacity for the ECS service. And likewise, you can see NLB EC2 service, NLB Fargate service, and all. Since these are like common patterns that are used in AWS, like to not reuse the code again and again, like there is a construct in CDK. Apart from this, there are also L3 constructs like CDK pipelines and others. So we'll get to see them in later videos. For now, we'll concentrate on this. And let me switch back to VS Code. Yep. So let me synthesize this piece of code. So you can see I've defined the LB Fargate service, and inside that I'm passing the cluster, the desired count. And apart from this, you can see that I've defined the source for my uh, ECS service. Source is actually a Python app which just returns hello from ECS container, and there's an endpoint for the health check. This is pretty simple, straightforward. So to deploy this in normal AWS, like how one would deploy this is that like we'll be building this first. We'll be building this into a container image, pushing that to ECR or other image repositories, and then we'll be referring that in our ECS service. We'll be creating a task definition, and then we'll um, define the service, create the service. That's what we'll be doing. But let's see that in CDK. So I have defined container image from asset. So during the deploy time, CDK would actually build using this particular Docker file, push it to the container repository that was created during the bootstrap, and then refer that in the template. So if I do a CDK synth, we'll be able to see that in the template. Yep. Now the synthesis is complete. You can see the ECS template. There is a VPC defined. This is because in the ECS stack, I didn't pass a VPC. So if you don't pass a VPC, it is going to assume that it has to create a VPC for you. That's why it's creating the VPC. And let's go to the service and services. Service has a load balancer configured. It has the container port, container name, everything, and it has the subnets also configured. Let's go to the task definition. Yeah, this is the task definition. And you can see that the image is actually referring to a ECR URI. This is the ECR URI that was ECR repository that was created during the CDK bootstrap. But if I go to the ECR repository now, let's go to the registry. So this is the repository. And if I check now, like the image won't exist. This is because during the synthesis, CDK won't build and publish this image. Like when you do the deployment, that's when CDK would build this image and then publish. So for that, you would also need Docker to be running. Yeah. Let me switch back to VS Code. And apart from this, you can see that within 10 to 15 lines of code, the template itself has grown up to 1,000 lines of code, right? So this is the advantage that you get with L3 construct. Like it abstracts common patterns that you see in AWS. So it makes your work easier. Like you don't have to rewrite every piece of resource that is needed. Common patterns like this are everywhere. So like the constructs also exist. If you don't see them in the CDK repository, like you'd see them in constructs hub. There also like you'd see many L3 constructs being written and published. And apart from this, we do have the assets.json file also defined. And inside this, you can see we have a lot of files to publish. And apart from that, we have the Docker images also published. So during the deploy time, CDK will refer to this assets.json file, and then it will publish this container image also that is needed for our stack. Okay, now let's see how we can pass values between stacks. So for that, I'll move to the VPC stack. So I'll edit this to VPC stack. And inside this, I have defined a VPC called ECS VPC. And to pass around this, I'll have to extend the props interface. So by default, the props for any stack would actually have some of the stacks properties only. Like we'll have environment wherein we'll be able to get the account ID, region and all. And apart from this, we'll get some more like the stack name, synthesizers used, or the tags. But if you want to pass around values, like first I'll have to extend this props. So interface, so I'll give it a name, ECS stack props, extends stack props, and then I'll define the properties that are needed for my stack. So in this ECS stack, like I would need the VPC. So I can define the VPC. VPC is of type EC2.VPC, and I'll change the type here. And in the bin where we have defined the ECS stack, we also need to define the VPC stack. So we'll import the VPC stack here, VPC stack, and VPC stack. So we are defining the VPC stack also. VPC stack. And to our ECS stack, we can pass around this value PC. Okay, so this is how we pass the value from one stack to another. So inside the VPC stack, I'm defining a normal VPC, and this is an L2 construct. So when you define this, by default, CDK would actually create a VPC, two subnets private, two subnets public, create an ad gateway, create an internet gateway, configure the route tables, everything for you. And inside this, I'll be able to get the VPC in props. So props dot VPC. This is how I'll be able to get the VPC from one stack to another. Now, if I do a synth, CDK synth, okay, so I'll have to define the region also. Okay, have to explicitly define the region. Okay, now we have two stacks synthesized. One is the ECS stack and another one is a VPC stack. So if I take a look into the VPC stack, like I said, there is a VPC configured. Subnets should be 4. There are 12 subnets. I think the default behavior has no, there is only, yeah. three subnets actually, three public and three private. And apart from this, we have the route tables. Everything that is needed for a VPC is already defined for us, so that when we deploy this, like we have a fully working VPC. And inside the ECS stack template, we'd actually have just the references, which should be an import. So we have the cluster should be in the service, right? Yep. The network configuration of the ECS service, we have the subnets. So these are configured as imports and exports. And inside the VPC stack, if you see the output section, yep, we have the exports defined here. So from the VPC stack, exports would be created, and inside the referring stack, that is the ECS stack, like we'll have imports. So that's how CDK would resolve your cross stack dependencies. It's pretty much straightforward to pass values between stack, but the issue is that like CDK would be resolving it to imports and exports. And if you're making any changes to the VPC stack that requires a replacement or like changing of these subnet IDs, then you'll get an error saying that there's a dependency in the ECS stack. So that's the only disadvantage. Apart from this, like you don't have to manually configure imports and exports when you're passing values between stacks. So this is how you pass values between stacks, and we'll see what contexts are. So now you can see that there is a context.json file generated. This was from my previous execution. I'll go ahead and delete this. Um, so let's edit this piece of code and do a lookup. Um, what is a lookup? In CDK, you can actually refer to existing resources that you have in your account that's already deployed, and then create your resources. So I can refer to existing VPCs in my account using a lookup. So this is all defined in the L2 concept, like L1 don't have this functionality. So what I'll do is I'll refer the default VPC that's created when the account is bootstrapped, and the property is default as true. Okay, lookup. Oops. Okay, now let's synthesize this. Syntax issues. Okay, let's synthesize this once again. Yeah, now we can see that the CDK context file got generated. And if I see the ECS stack for the service, the subnet IDs are actually hard coded. So these are the subnets that I already have in my account. So this is the default VPC that is created in the region, and these are the subnets that were created alongside it. And what happens behind the scenes is that when you define a lookup and then like define the properties of the lookup, what CDK will do is like it will query your particular account, like using the lookup role that was deployed during the bootstrap, like using that role it will query your account, fetch the resources, and most of the time it will cache it here in the context. For VPC, it does cache it, and you can see that the account, this is my account ID, and we have the default VPC. This is the default VPC. It will cache all the values like the CIDR block, owner account ID, the subnets. Like I think I only have the public subnets now because those were the default ones deployed. So yeah, all the public subnets and the if there are private subnets, those also would be available here. And using this file, CDK would reuse. And it is a common pattern to commit this file also so that you have predictable deployments like down the line, like if you're deploying from your Git or your pipeline, there you don't get any surprises, so that you commit this file also. And say you add any subnets to the VPC, like you'd still have to delete this context and then do a fresh lookup. Otherwise, like that newer subnets won't be discovered by CDK. So using this lookup, CDK would actually what do you say, reuse these values in these stacks. So that's what happened here. We can see that the subnets have been substituted here. There are much more properties in this lookup, like you can look up by the name, look up by the type, or the tags. Those are available. And now there is also a feature in CTK that will look up using the Cloud Control API. Like behind the scenes, many of the resources have switched to Cloud Control API, so the lookups have been like pretty straightforward to implement. And yeah, we'd probably see much more resources implementing this down the line. And this is pretty much it about the lookups. Now let's move on to the last and final topic that I wanted to discuss, which is passing context values to your stack. Context values are a way of getting values into your stack during the synthesis or deployment time. You can actually use these values to, conditionally create resources or like process logic using these key value pairs. So let's see using an example. For example, okay, let's move on to the last topic that I want to discuss in this video, which is context values. So context values are a way of getting values during your stack synthesis or deployment time. And using these key value pairs, you can actually conditionally create resources or loop through or process logic using those. For example, if I want to conditionally name this cluster, the ECS cluster here, all I have to do is I'll have to define a variable class cluster name, and then I'll get the context value, get context, and probably I'll define a cluster name. So this is the key that I have to supply during the synthesis or deployment. So if I miss to supply this, then CDK is going to assume that this is not provided, and then it won't be able to get the value for that. So this is also case sensitive, so that is also something to keep in mind. This is the method to get the context values. So during synthesis or deployment, I'll have to pass using -c. So let me refer this cluster name here for the ECS cluster. Then, yep, let's try synthesizing this. And we can see the ECS stack, and you can see that the cluster name is defined as Murli. So that's how you pass context values. You can pass as many as key value pairs as you want to the stacks. And if I change this, this should also change. Yep. But if I miss to pass the context value, CDK is going to assume that it doesn't exist. And yeah, you'll have a difference in behavior. So if you're defining context and then you're missing, so you'll have unexpected behaviors during the stack deployment. So in this particular case, we are removing the cluster name, so that actually means a cluster replacement. Now let's try deploying a sample of this to understand how this will all fall into place. I'll comment the Fargate service for now, because when I tried to deploy the Fargate service, there was an error saying that my account is doesn't have support this service yet, because it's a very new account and I kept getting the error. So I'll change to queue processing service. This is also an L3 um, con construct, and this deploys an SQS queue, and then like it doesn't connect, like it pass environment variable to the ECS service. That's all it does. So I'm defining the ECS service, and then we'll have the cluster also. And I don't want the VPC stack to get deployed now. Uh, I'll remove the VPC, and from here also I'll remove the extra properties that I've defined. Okay, so all we want to have is the cluster and the service. So let's change this to demo. We'll use the default VPC itself, and I remove this. Okay, let's do CDK synth and Q. Synthesis is okay. We'll deploy in US West 2. CDK deploy. So during the deployment time, we get to see how CDK would build the um, container image and then publish. So now it's publishing the template. Okay, yeah, the Docker. So this is what you would get if Docker is not running. So to build the image, Docker is needed, or you'd have to define which one to use. Like you can use Finch also. And yep, I've started Docker. Now let's do a CDK deploy, and let's wait for the build to complete. Yeah, now it's building the container image. This is a pretty old um, container image definition. That's why. Um, yep. Okay. Deploying the stack, and now if I switch to ECR, I'll be able to see the container image pushed here. Yep. So this is what CDK does behind the scenes. It'll build and then it'll tag, push. It'll create a uh, hash also for the image so that like whenever your source code changes, it'll automatically build and then push. So rollbacks would also be easier when you have this mechanism. So if you want to roll back, it'll go to the previous hash. Like if it's using a same static name, like the rollbacks would be harder. So let's see clusters. Yep, the demo cluster is being created. We'll see the service being created in a while. Most probably it's deploying the SQSQ and others, other roles. Switch to flat view. Yep, it's creating the security group, log groups and everything. Right. It's actually going to take a while. Yeah. You can see that the ECS service is being created. Yeah. Now task would also come up, and then there would be a SQSQ defined to this. So I think this is all for this video. We've discussed about L3 constructs, passing values between stacks, context values, and lookups, and how CDK leverages these for your deployments. Thanks a lot for watching, and stay tuned for the next video.